Okay, and what the triangle mid-segment theorem tells us is the mid-segment of a triangle is parallel to the third side of the triangle and is half the measure of the third side of the triangle. Oops. Okay, so the midsegment of a triangle is parallel to the third side and half the measure of the third side of a triangle. So, if I have a good old triangle, this is what it would look like. Okay, let's say this is A, B, C. Okay, and I took the midsegment of both sides, or the midpoint of both sides. Okay, so for example, this would be congruent to this. This would be congruent to this. That's how we would denote that that is the midpoint of both sides. Okay, and then if I draw my segment and it is parallel to the third side, then this segment here is half the distance of the third side. Okay, so if I label this D and E, okay, DE represents the midsegment. Okay, so if AC is 12, DE would be 6. Okay, if DE equaled 2x plus 2 and AC was 24, how could we solve for x? 2x plus 2 is equal to what? 24 divided by 2, which is 12. So then you would solve for x. So x would be 5. But that is the style of question that you would get. It would be something algebraic. Okay, so if this is 1/2 of AC, you could either divide it by 2 or multiply 2x plus 2 and set it equal to 24. You could do it either way. Okay, but that is what we call the triangle mid-segment theorem. Okay. Let's go back up to the top to kind of look at these a little bit further. Okay, number 1 says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So we're using diagram C and proportion E. Okay, so it's saying that AB over BC is equal to DE over CD. Okay, notice that the only time this works if you're comparing parts of a side, okay? You wouldn't be able to compare CB over AB and BD over AE, because notice that BD and AE are actual sides of the triangle, okay? Whereas CB and AB is a part of this triangle, okay? So when you have this little line in the middle here and it's being divided on the other side, think of that as like a fraction bar. So if I had 2/3 here, okay, obviously this would need to be 4/6 because it needs to be proportional. But look at this as a fraction bar, and that's how you would set up your proportions. So 2/3 equals 4/6. Okay, so that's the easy way to look at the fraction. Or if you flipped it, you could say 3/2 equals 6/4. Okay, but use that as a little guidance for how to set up the proportion. Okay, same thing over here. Okay, for your transversal being or your parallel lines being intersected by the transversal. Think of this middle parallel line as your fraction bar. Okay, so I'm just going to keep using 2/3 and 4/6. But if this was the case, Okay, using that as your fraction bar, you have 2 over 3 equals 4 over 6. Maybe one of those was an x, and you would be solving for that unknown side. Okay, and then the last part would be diagram A. Okay, using that bisector as the fraction bar. Okay, again, let's go 2/3 and 4/6. Okay, again, using it as the fraction bar. So 2 over 3, 4 over 6. And we're about to see this in application on the next set of problems. Okay. So, it's saying here to find the length of AB. Which theorem would we use? Pardon? Triangle proportionality theorem. And what ratio would we set up? 18 over x equals 24 over 20. So again, imagining this as the fraction bar, you have 18 over x equals 24 over 20. Okay, so you have 24x equals 360. What does x equal? 15. Okay, again, it only works when you're comparing a part to a whole. Okay, you cannot compare BD to AE because those are both the entire side length. Okay, so do not make that comparison. Okay, number 2, which one are we using? Angle bisector theorem. If this whole thing is 16 and this is Q, how would I name this piece? 16 minus Q. Is it Q minus 16? No. If it was Q minus 16, that would mean that this entire side is greater than 16. Okay? It is 16 minus Q. Okay, so again, pretending that this is like a fraction bar, this little angle bisector, what would be my proportion setup? What was it? Not 16 over 16 minus Q. Look at your pieces. Very good. Q over 16 minus Q equals what? 36 over 28. Does drawing these little, like, imaginary fraction bars help, or is that confusing? No, that helps. Okay. So now we're going to cross multiply. So you have 28Q equals 36 times 16 minus Q. What's 36 times 16? 576 minus 36Q. What's 28 plus 36? We have 64Q equals 576. Divide by 64. What does Q equal? 9. And you can always go back and double check your work. If Q is 9, what's 16 minus 9? 7. So does 9 over 7 equal 36 over 28? Yes. Divide both of these by 4 and you get 9/7. Okay. Number 3. What are we using? Number 3, what are we? Proportional segments is when you have parallel lines cut by the transversal. That's this one. Okay. Can we use triangle proportionality theorem? Are you comparing parts to the whole? So in order to figure out ED, you would have to compare these two bases. Do we do that with triangle proportionality theorem? No. Okay, remember, you can only use triangle proportionality theorem if the numbers are all on the outside. Okay, you can't compare the bases because the bases represent the entire side here, the entire side here, whereas these are just parts. Okay, so the proportionality theorem only works on the outside. Nope. Here's a hint. It's nothing on that front page. What did we do last time? Okay, that's to prove that they're similar. So let's see. Are these triangles similar? Let's look at triangle A, what is this? AGB, which is 6, 5, and 4. And then you have another triangle, which is AFC. And all you know for this is what? That AC is 10. Okay, and then you have your huge triangle, which is AED. And all you know is this is 14, and this is what we want to know. Okay, how do we figure out if these triangles are similar? What do they have in common? Their bases are parallel, but what does every single triangle have in common? The same vertex, A. So you know that you for sure have one angle in common. What else do you know? The corresponding angles, which ones? DEF corresponds with what? GFC corresponds with what? AGB. Does everybody see that? How these lines are parallel? So all the corresponding angles are going to be congruent. So now you know they're similar by what? Angle, angle. Okay? So you had A in common, and then you have these corresponding angles all in common. Okay, we can't do side, side, or side, angle, side, because you don't know enough side lengths in each of these triangles. Okay, so now we know they're similar. Okay, and what do we know about similar triangles? Sides are proportional, and angles are congruent. Okay, so now if we know that this side's 4 and this side's 5, this side's 14 and this is our unknown, how can we solve for ED? 4 over 5 equals 14 over x. So you have 4x equals 70? So what does x equal? Okay, so that's the hard way. Okay, notice that for number 1, you could have used the same method, but there's shortcuts, and that's what we were learning here. Okay, because if you're doing number 1, they share angle C, so that would be in common. They share, this angle A is corresponding with CBD, so you know that those triangles are similar. Okay, and if we wanted to figure out the length of AB, well, you could say, you could pull apart your triangles, and you have CBD, which is 18 and 24, CAE, 24 and 20 is 44, and you would need to figure out this side, so you could set up that proportion, and then when you figure out what x is, subtract 18 to get just AB. So there's multiple avenues for figuring out how to solve for these pieces, but obviously there's quicker ways than others. So on this one, I would be looking for you to use that proportionality theorem because it's quick and easy, and it saves you a lot of work. Whereas this one, I need you to be able to identify that you can't use the proportionality theorem because it's comparing the bases instead of parts. Okay. Number 4, which theorem are you using? the segment theorem, okay? So, again, if you use that middle parallel line as your fraction bar, how are you going to set up your proportion? 10 over x equals minus 2 over 12. Ooh, this one's good. Okay, cross multiply. 10 times 12 is 120. And then you have x times x minus 2. When you distribute that, what do you get? X squared minus 2x. Ooh, now what? Get it into standard form, or set it equal to 0 and factor. So you would have 0 equals x squared minus 2x minus 120. Who remembers how to factor? Kayshan, how often do we factor in Algebra 2? Okay, so we're looking for the factors of negative 120 that are going to add and give me negative 2. So what times what gives me negative 120? Negative 12 and negative 5. 10. Okay, and when I add those together, what do I get? Negative 2. So those are my magic numbers. Multiplied, they give me negative 120. Added, they give me negative 2. So I have 0 equals x minus 12 and x plus 10. Okay, so what are my two x values? 12 and negative 10. Okay? Anytime that you have two answers, I need you to test them and make sure they're not going to spit you out any negatives. Okay, is there any of either of these solutions that don't work? Negative 10, why? Negative 10 minus 2 is negative 8, or negative 10 here would be negative 10. Do we have negative distances? No. So only 12 would work. But you have to test both of them, because maybe this would have been like 6x minus 1 or something, and then negative 10 would have worked. Okay? You have to make sure that you plug them in. Don't just automatically eliminate the negatives. Make sure they don't work. Okay, number 5. The figure is a diagram of a cross-section of an attic of a house. A vent pipe comes through the floor 6 feet from the edge of the house. What is the distance x on the roof from the edge of the roof to the vent pipe? That was a lot of words. Okay, can we use triangle proportionality theorem? You could, how? If you rotate this, if this is x, what would be this little piece? 18 minus x. So if I set up my proportion, what would it look like?
X over 6 equals 18 minus x over 5.
So if I use this as my fraction, what would your proportion look like? 6 over 9 equals
8 over 18 minus x.
Where'd you get 8?
Oh, sorry,
X over 18 minus x. So when I cross multiply, you have 6 times 18 minus x equals 9x. What's 6 times 18? Minus 6x equals 9x. Add 6x to both sides. You have 108 equals 15x. So what does x equal? 7.2. 7.2 what? Feet. Okay, what's another way you could have solved that? You could have made them two triangles and then proved that they were similar. Because they share this angle here, and then they both have a right angle, so you know those are congruent. So that's similar by angle, and then set up proportions that way too if you wanted to pull them apart. Okay, so there's multiple avenues to solve. Okay, number 6. What segment theorem are we using? Triangle mid-segment theorem. Okay, so go based off what you know so far in your picture. If you know that these are congruent, how are we going to solve for y? Set them equal to each other. So 2y plus 6 equals 3y minus 9. So what does y equal? Very good. Okay, and then to figure out what x equals, what do we know about this?
That's half, or 6x plus 11
Okay, so 2 of these equals 1 of those, right? Or 1/2 of this equals this. Okay, so you have 2 times x plus 23 equals 6x plus 11. 2x plus 46 equals 6x plus 11. Subtract 11 from both sides and you get 35 equals 4x. So what does x equal? Very good. Okay. If you know that this is 60 degrees, okay, and these two sides are congruent, what does this angle have to be? 60 degrees. So what's this angle? So what do we call this? An equilateral triangle. Okay, so if our mid-segment is 5, what's the length of one of our sides? 10. So then what's x? 10. Yeah, something like that. Okay, so being able to identify equilaterals as well. And proof. We're almost done. Last 2. Okay. Statement. Reason. Alright. When we prove triangles are similar, what does that tell you about the two triangles? Sides are proportional and angles are congruent. So far we know R and S are congruent, but we want to prove that QR over TS equals RP over SP. What do you think we have to do in the process? In order to prove that that proportion is true, what do you think we have to do first? You have to prove that they're similar. And then once you prove they're similar, then the definition of similar triangles is that the proportions are equal. Okay, so remember that similar triangles have congruent angles and their proportions are equal. Okay, so first one is our given. Angle R is congruent to angle S. Somebody give me something else we know in this figure.
Angle P is congruent to angle P.
Okay, but how should we name that since there's 4 angles with P?
Angle PR.
Angle QPR is what? And why is that? Definition of vertical angle. Okay, so then by default, T and Q would be congruent. Okay, now what? Okay, Jen? No. Because what's our theorem? Just angle, angle. It's implied that the third one's congruent. I just marked it for naming purposes. Triangle RQP and what? STP are similar, and why is that? AA similarity. Okay, so now that we know they're similar, what do you know about their side lengths? They're proportional. So you're already at your final step. QR over TS is equal to RP over SP. And what do you think the reason would be? Definition of triangle similarity, or similar triangle. And you're done. Okay, so say we had to use side angle side. Okay, and our last step was to prove that angle 3 is congruent to angle 2. Again, once you prove the triangles are similar, then your last step would be that the angles are congruent, corresponding angles are congruent, corresponding sides are proportional, and that would be because of triangle similarity. Okay, number 9 says write a similarity statement and identify the theorem or postulate that proves the triangles similar. What do you suppose? Okay, so we don't use the triangle proportionality theorem to prove triangles are similar. We use that to solve for side lengths, given that they're similar.
Side angle side.
Side angle side, how are you going to prove that, Bill? What angle are we using? D, because that's what's in common. Okay, so if you were to pull apart your triangles, you have A, B, D, and G, C, D. Okay, you know angle D is congruent. Okay, you know DA is what?
3.
DA? 8. And DG is 5. DB is 7. And DC is 1. Are the sides proportional? So you have 8 over 5 is equal to 7 over 1. Is that true? Okay, so are the triangles similar? No. Okay, what if I would have made this a 10? Oh, that would have made this, what, 16? Then would they be similar?
Yeah.
Yes. Okay, so at first, no, if I would have made that a 10, which I think it probably was a typo, to be honest, then it would be similar. Questions? Okay, so the proofs are the same as what we did last class, except for now, if it wants to say that side lengths are proportional or angles are congruent, all you're doing is that extra step. And then the reason is definition of triangle similarity. We're good? Okay. You guys are going to have